So what is big data and what's happening in shipping? So basically we have a shift from noon data to autolog, where noon data you have 5 to 20 data points, and you actually per 24 hour, and you're going up to tens of data points per 15 seconds. So you have issues. You have more data and higher frequency. So you have issues with data handling. You can have data backing up in the system if you have issues. The regulations actually are causing some of the problems. You have more regulations, so you need more data capture to show for these regulations, so more data. And in essence, you have issues with analyzing this data, with the big data analytics. You have problems with the trends actually being masked by the amount of data you have. So in the past, you could actually see very well what was happening to your vessel and the consumption. Now, because you have such a big volume of data, this is masking or actually can bring you to the wrong conclusions because of this. This actually has problems as well when you want to transfer the data back to the office, for the management office. And as well, or storing the data. You know, that's why we start using cloud solutions for storage. So it's a totally different game. And in essence as well, you have the various data sources which you have to combine in one when you want to analyze all this data. So for sources, you have the performance data, which you go from a noon report, which is one set per 24 hours, to autolog, one set 15 seconds, and that can lead to about 6,000 more data points per 24 hours. So just from the frequency increase. So then you got consumption data, speed, environmental data, machinery data, the design data and the third-party data. You have to try and combine this, which usually is very different to the other data you have, and try and combine it in a meaningful manner to actually help with the analysis. And in essence, when you go for the performance data, if you're looking at autolog, you have to capture the performance for the whole voyage, starting from route planning all the way alongside. And you want to have the least amount of human intervention. So you have pure, shall we say, pure data. But one of the issues is how do you record events? You don't want to have the crew having to say, okay, this is the vessel leaving from port. We are now doing a ballast exchange. So you have to find a robust system to actually manage events. You have to keep the crew in the loop, though. You don't want to have them as just passengers on the vessel. They need to know what's happening. So you need KPIs. You may need some ways to show the data to the crew. Maybe you have a new system on the bridge, and they need to be aware of what's happening. So because they are still part of the vessel, they're not passengers. In general, this is a kind of autolog performance monitoring system, how it would be considered. So you have a data logger here, which looks at the torque meter, main engine flow, auxiliary flow, all the flow meters, which is basically the machinery performance monitoring. You can have pressures from the main engine as well. You have a section which is a login module, which is a data logger, which transfers things to a database, which is then in the voyage module, which is transferred through a communication link. We can get information for the ECDIS, you can get it from a load computer. In some cases now, we're looking at structural loads, you have motion sensors as well on the vessel. So trying to get as much information as possible. So looking at data flows, the first section is the source systems. So you can have all of these or some of these feed in information. The classic is the noon report data, which used to be what was considered as performance data, and vessel design data. Now you can have autolog data, pure autolog data, you can have a combination of data. You have third-party data, the weather, you can have hindcast, AIS. All this feeds into the actual validation section, which is in the middle, which is a data lake and a data warehouse. The data lake is the big data platform, which is used for validating the data, consolidating the data, sorting it out. It actually has to make sure as well that timestamps from all the data actually match. So you're actually doing a proper analysis. As all this data may be from a different source, a different format. The formatting of the data is very important. The data warehouse is used to store historical data or data from other vessels, from the sister vessels. So you can actually compare sister vessels as well. All this data is then transferred to the presentation layer, which you can see here, which is the vessel performance management software. You have a standardized analysis. When you're talking about such big data sets, you need a standardized and automated system with maybe an overview from a performance team that will actually look at the data, but it has to be standardized. And then you have alarms, KPIs, and assist the actual analysis. And then the data should be displayed in a standardized version, and possibly with some opportunity to customize this for the client. And one final thing which is useful is this data quite often may be found to be not exactly what the company wants, the client wants. So you have to be able to provide the data in a simple way so they can do their own analysis if they want. So you actually assisting the client to actually do their own analysis, which could help as well. Sorry. The validation section. So there's a two-stage validation. One is on board the vessel, and one is in the data lake. It's very important to have an onboard validation to try and catch problems with the data before they are transferred to the shoreside and to the actual analysis section. So you have rules for the sensor performance. You have to validate on spikes, outliers, drifting, any malfunctions of the sensors. And any data which is found to be invalid should be transferred in another location to be looked at and analyzed, and then maybe disregarded in analysis. You never delete any information. You just disregard it. It always needs to be kept for records. Environmentally, on the side, on the environmental sensors, you can have hindcast data to validate the motion, the vessel. You can have motion sensors, which actually will validate the motions of a vessel compared to what the actual environmental sensors are telling you. And in addition, you need some training of the actual rules of the sensors to see, based on the position of an anemometer or a motion sensor, you need to train it. It's not a standardized thing. There could be some masts that block the anemometer in some parts. So it's important to actually have a customized validation regime. So the validation in the data lake itself, you can have, you validate the data with a physical model, which is based on the actual data, physical data of the vessel. So the hydrostatics and all the other data. You can have a data-driven model, which could be the historical data provided beforehand. Or if you do not have the historical data, you can run the system for a short time and get this data. And then a combination of the two. Looking at vessel performance, the analytics, we're currently looking at the actual, it's a non-dimensional coefficient of friction, which is then taken into an increase in power, then an increase with the SFOC, an increase in fuel used. And you can see the effects of any propeller pollution, any dry docks here. Same for the actual main engine. Looking at analysis on the main engine based on the actual main engine manufacturer recommendations or any ABS recommendations. A few more versions of some indexes. You can have a charter party compliance. You can verify the performance of upgrades. Trim tables usually is for not for tankers, and it's for container carriers. Base load analysis, operational benchmarking, all these can be seen when you got big data. The same way, voyage performance. You can capture all the voyage events, SEMP, the emissions, voyage plan and prediction. And environmental performance. As you're recording all the data, It's very easy to actually go in and do reports on the actual environmental side of things. The SEMP updates and evaluations, emissions reporting, all the MRV, the IMO data collection reporting, it's all included as it's based on performance. So that's included as well. Another important side of things is presenting the data. It has to be a standardized format as well, so the client is used to looking at this and you don't change it all the time. You can use bar graphs, 3D plots, word maps. Depending on the data sets, you use a certain one. And filtering and overlays and bin ranges are used to make sense of the data. So you can customize what you obtain to get to conclusions. And statistics, you can qualify the data. Reports, again, as I said, very easy to obtain the reports, which are required by regulation now. And finally, as I mentioned, if you sort and filter the data and provide this, the client can actually, the user can actually use that for his own analysis. So for the future of big data in shipping, we can see an integration of all the systems, integrating the structural monitoring as well, with the motion sensors and performance in the seaway, operational decision support, cargo tracking as well, which we have seen in some of the presentations before, remote operations, and all this becomes centralized knowledge and could feed back onto the actual future design of vessels. And a very important thing that we've seen today, obviously, is cybersecurity as well, which needs to be taken into consideration.